It's pretty wild. We have these incredibly advanced AIs today, right? Models capable of writing beautiful poetry or synthesizing massive blocks of complex code in seconds. But then they completely fail when you ask them to simply book a flight or execute a specific background removal tool. It's like we have these massive large language models that are fantastic conversationalists, but when it comes to being a master tool user in the real world, they just kind of stumble. Well, enter a breakthrough system called Gorilla. It's a fascinating project from researchers at UC Berkeley and Microsoft Research that aims to change exactly that. Welcome to today's Explainer. Here is the game plan for today. We're going to start with the API hallucination problem, introduce the Gorilla LLM, break down how the methodology works, look at some results and real-world examples, and finally, wrap up with the impact and key takeaways.
All right, part one, the API hallucination problem.
So why can't a massive language model just, say, book your entire vacation or run a complex code pipeline for you? Well, the fundamental limitation here is that these models are confined by the information stored in their fixed, static weights. Basically, they have a limited frozen context. The real world, though, it changes every single day. And to interact with it, an AI needs to use external tools. Specifically, it needs APIs, or application programming interfaces. But the web has millions of these APIs, constantly overlapping, constantly updating. Expecting a static AI to perfectly memorize all of them, that is exactly where the system breaks down.
And when that breakdown happens, we get what's known as API hallucination. Now, this isn't just the AI making up some fake historical fact. This is when an AI confidently generates an incorrect, completely non-existent, or mismatched tool command instead of the correct API call. It might write a line of code that looks perfectly syntactically correct, looks great, but it's calling a software library that quite literally does not exist.
When tasked with finding an audio-to-text API, state-of-the-art models actually stumble pretty hard. GPT-4 hallucinates a directory, Claude picks an incorrect library entirely, and the craziest part? They fail with absolute confidence. But then there's the Gorilla system. It correctly identifies the task and suggests a fully functioning API call, succeeding where the others hit a wall.
Which brings us to part two, introducing the Gorilla LLM.
To really wrap our heads around the solution, think of APIs like a massive, sprawling warehouse of power tools. Current LLMs, they know about power tools in a general sense. But if you send them into that warehouse to do a very specific job, they often grab the wrong brand, or worse, they come back with a tool that they just completely imagined in their head. Navigating this vast space requires a totally different kind of AI capability. So enter Gorilla. Think of this model as the ultimate master contractor. Built on top of a Llama 7B base model, Gorilla is specifically fine-tuned not to just chat with you, but to actually read the instruction manual, meaning the retrieved API documentation, and then grab the exact right tool for the job.
Let's dive into part three, how the methodology works.
The researchers built a massive data set called API Bench by scraping thousands of machine learning APIs from hubs like Hugging Face and TorchHub. But the real magic here is their retriever-aware training pipeline. Let's trace it step by step. First, the input. It takes the user's prompt plus the most up-to-date API documentation it can find. Next, the process. The Gorilla LLM parses the complex constraints of your prompt against that provided manual. Finally, the output. A fully qualified, completely accurate API call. Let's look at how this flows in practice. Say a user asks for something fun, like, I want to see some cats dancing in celebration. That prompt goes straight to an information retriever, which fetches the reference API docs. Both of those pieces of info are then fed directly into Gorilla. By training the model this way, it adapts to whatever fresh documentation you hand it. But here's a really critical question. How do the researchers actually prove the model isn't just hallucinating again? Well, they use a clever technique called ASD subtree matching. Instead of just checking if the code runs, which is honestly pretty hard to evaluate objectively, they parse the AI's generated code into an abstract syntax tree. Basically, they compare the family tree of the AI's generated API calls against the real, verified family tree in their database. If the AI calls for a branch that doesn't exist in reality, like a hallucinated directory, the system flags it instantly as an error.
Moving to part four, results and real-world examples.
There is a striking leap in zero-shot accuracy on TorchHub APIs here. Now, zero-shot means no retrieved documents are provided, just the raw prompt. The base LLM model scores around 14.5%. GPT-4 hits 38.7%. But Gorilla, it absolutely blows them away with an accuracy of 59.1%.
That's a jump of over 20%. That is exactly how much the lightly fine-tuned Gorilla model outperforms the highly complex GPT-4 in zero-shot API functionality. It really just proves that fine-tuning an AI specifically for tool usage yields profound performance bumps over general, jack-of-all-trades models.
So what does this look like out in the wild? Imagine you want to remove an image background, but the repository just upgraded its backend from ResNet 50 to ResNet 101. A traditional LLM, relying purely on its static memory, will confidently call the old broken API. But Gorilla reads the newly provided documentation at test time and flawlessly adapts to the ResNet 101 update on the fly.
Which brings us right back to those dancing cats. When the user inputs the prompt, "I want to see some cats dancing in celebration," Gorilla doesn't just chat with you about cats. It correctly fetches the Stable Diffusion Pipeline API, inputs the exact right parameters, and the execution result is a beautifully generated image. It successfully bridges the gap between natural language intention and complex computing execution.
And finally, Part 5, Impact and Key Takeaways.
Now, to give a completely fair assessment, Gorilla's strengths are undeniable. Massive accuracy improvements, and the ability to instantly adapt to API changes. However, there is a catch. If you pair Gorilla with a mediocre information retriever at test time, it can actually misguide the model and degrade performance. Its success relies heavily on having high-quality, well-maintained API documentation databases. To sum it all up, Gorilla fundamentally solves the tricky problem of reliable tool usage. By introducing retriever-aware training, it overcomes static weight limitations, mitigates those frustrating hallucinations, drastically outperforms general models in specialized tasks, and remarkably, it can even reason about specific constraints, like choosing a model based on its parameter size.
The researchers note that transitioning AI to invoke the vast space of change in cloud APIs could literally transform large language models into the primary interface for the entire web. Just imagine simply speaking, and an AI flawlessly controls the internet's sprawling infrastructure on your behalf. If AI becomes the ultimate master contractor for the web, will we ever need to manually click, scroll, or code again? Thank you so much for joining me for this explainer, and keep learning.